everyone, to another episode of Fun with Limits. Yep. My husband told me that I should do something goofy in every video, like have a fun little transition or something. Like, this video is presented to you by rational functions. But I think I'm goofy enough without, like, you know, scripting the goofiness. So, anyways, in this video, we are going to explore a limit, and we're going to do that numerically and then graphically. And then we might even do that algebraically in this particular problem. So in this problem, I want us to discover what is the limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2. So I want us to determine what is the limit as x approaches 2. And what I mean by that is, if 2 were defined in this function, what would it be? To do that, we want to analyze the pattern. And so let's start by doing this numerically. So numerically, we're going to fill in a table of values. So of course, we'll have x first, and then we'll have f of x. And in this table of values, we want it to be centered around the number in question, which is 2. If I were to simply plug in 2 to this equation, it's going to say undefined. And it's going to say undefined because we're dividing by 0. Really what it ends up being when I try to plug in 2 is 0 over 0, which is an indeterminate form. We don't have enough information to say what that actually is. So because just plugging 2 in didn't work, we need to analyze the pattern. And from the left, we want to get as close as we possibly can to 2. And from the right, we want to get as close as we possibly can to 2. And if, as I'm looking at this from the left and from the right, I'm approaching the same value, that is what the limit is approaching. So from the left, we could try 1.999. We could try 1.99, and we could try 1.9. It is important to have more than one value that you're looking at to make sure that there's not some other discontinuity happening, to make sure that there's not a random jump or something like that. And then maybe from the right, we'll look at 2.0001, 2.001, 2.01, 2.1. And again, you want to look at a couple of different values there. I mean, maybe I have too many, but that's okay. So let's go to our graphing calculator. F of x equals, and in the numerator we have x squared minus 3x plus 2. And then our denominator we have x minus 2. And for fun, I always like to at least try plugging in 2, because if f of 2 existed, then I wouldn't have to do all this other business. F of 2 does not exist, so I do have to do the other business. So let's go ahead and click this gear, and let's change this to a table. So the function is still there, but now we're going to look at the table, and we want the table centered around the value 2. I don't know how to delete numbers on here, so let's just go ahead and start by 1.9. Make this 1.99, 1.999. We'll keep 2 in the center. 2.0001, 2.001, 2.01, 2.1. And what we want to do is we want to look at these values to analyze what would make sense to be in the middle. What would make sense to be right there? And so as we look at these values, it looks like 2, when x is 2, it looks like it's approaching 1. Doesn't it look like it's approaching 1? So I will fill in the numbers we just discovered. So we have 0.9, we have 0.99, 0.999, and then we had 1.0001, 1.001, 1.01, and 1.1. And so it would make sense for this question mark to be 1. And that is what the limit of this x as a limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2, the limit of that equals 1. Now, let's look at this graphically. Let's see if that makes sense graphically. So here's our graph right here. And let's just play around with this for a second. And there's that hole right there. As we move towards x equals 2, so x equals 2, as we follow the curve from the left, it looks like it's approaching 1. As we follow the curve from the right, it looks like it's approaching 1. So that's how you could solve it graphically. Is what would we fill in that hole with to make this true? Now, the last way I want to show you hones in on some pre-calculus skills. So in pre-calculus, we would have called this a rational function. We still call it a rational function now. And in pre-calculus, you might have been asked to simplify this so that we could graph it. And when you simplify it, I might ask you to find the holes. I might ask you to find the vertical asymptotes and things like that. So when you simplify this in pre-calculus, you factored the numerator. Oh, that wasn't right. X minus 2 and x minus 1, because negative 2 times negative 1 is positive 2, and negative 2 plus negative 1 is negative 3. And then what you would do is you would cross out any like factors. But we'd have to note off to the side, I crossed off something that x would have been equal to 2. My simplified function here is x minus 1. And in pre-calculus, what we figured out was, then to find the hole, you would plug in the x equals 2. So when we plug in x equals 2, well, 2 minus 1 is 1. And that is what the limit is approaching. The limit is approaching 1. So numerically, one of the ways to solve this, or not numerically, numerically is a table, graphically is a graph. Algebraically, to solve this, we could say the limit as x approaches 2 of x squared minus 3x plus 2, or x minus 2. Well, when I plug in 2, I get 0 over 0. So my next step is to simplify. And when I simplify this, I'm going to get x minus 1, but I still have the limit as x approaches 2. Now plug in the 2. 2 minus 1 is 1. We use the operation of the limit, and that would be our answer. So, numerically, you make a table, you get as close as you can to that value. Graphically, you graph it. And you approach it on the left and you approach it on the right, and if it is approaching the same value, that value is the limit. And algebraically, you see if there's a way for you to simplify. And if you can simplify, then you plug the value the limit is approaching into your simplified expression.